Righto. Now when we are multiplying or dividing, then it's really straightforward. We just multiply straight across, but aha! We need to do a couple tricks first to make sure that what we're doing is actually going to work. So again, we don't want any mixed numbers. So we're going to do 7 times 1 is a 7, and then add a 4 to that, and 7, 8, 9, 10, 11. That gives us 11 sevenths. Now, we just want to get rid of the mixed number. We don't need to have a common denominator anymore. Nobody cares. So if we're multiplying, we just go right across. 11 times 3 and 7 times 5. 11 times 3 will give us 33, and 7 times 5 will give us 35. So our answer is just a plain old 33 over 35. So not like addition. Addition we need, and subtraction we need a common denominator. But for multiplication and division, we don't. We go right across the tops of both. This is for multiplication. Can I reduce this anymore? I don't see any common denominator off the top of my head, and so I'm going to say nagada, not going to do it. Now, division, we got to remember, division is really just multiplication flipped around. So when we're dividing, we're going to keep, we're going to change, and we're going to flip. So what are we going to keep? I'm going to keep the first fraction the way that it is. What am I going to change? I'm going to change that into a multiplication sign, because really division is multiplication of the reciprocal, which is this fraction flipped upside down. So dividing by a fraction will give you exactly the same result as multiplying by its reciprocal. So if I were to give you an example, let me choose a random fraction. We're going to do 2/3 and we're going to divide it into 2. We're going to divide it into 2 parts, which is 2 over 1. So if I do keep, change, flip, I would do 2/3. I would change this to multiply, and I'm going to multiply it by 1/2. It's the same diff. I'm still going to get half of what I started with. So that's just, I hope, a simple illustration. We keep the first, we change division to multiplication, and then we flip this so that the 2 is on the bottom and the 3 is on the top. And then it's just plain old multiplication. So once we've done keep, change, flip, we do 5 times 3 gives us 15, and 7 times 2 gives us 14. So now we want to actually move that back and make that back into a mixed number. So how many, if I'm going to get 1 here, how many 14ths do I need? I actually need 14 14ths. Just like 2 halves make a whole, 14 14ths will make a whole. And to that, I need to add 1 to make the 15th. So it's actually just 1 and 1 14th. There's our answer. Now to put it into practice, here I have multiplication. It's the same. I just go straight across. But aha, I still want to change these mixed numbers into improper fractions. 5 times 1 is 5, plus 2 is 7. So I have 7 over, I keep my denominator, times, so there's no flipping involved here. 5 times 1 is 5, plus 4 is 9. Okay. And so that gives us 63 over 25, because we did 7 times 3 is 9, and 5 times 5 is 25. Okay, so that's obviously going to be a mixed number because the top number is larger. So what is my top number going to be? Let's see, if I had 25 25s, that's 1 whole, plus 25 25 mores, that is at least 2 wholes, because that gives us 25 plus 25 is 50. And what's the difference between 50 and 63? Well, that's going to be 13, isn't it? So if I had another 13 25ths, that means I've got 2 wholes. So I've worked out that there are 2 sets of 25, which make 50 up here. And then I'm left with 13 25ths. Boy, that's an unwieldy one. That's fun. That's fun for the whole family. I'll bet you there's a way to do that on the calculator. So now this one over here, 8 over 3, and so we're going to keep 8 over 3. We're going to change division to multiplication, and we're going to flip this to its reciprocal. So 2 over 9 becomes 9 over 2. Now, I could go ahead and I could multiply 8 times 7 and then work it all out that way. That's going to work. I can do it. If I did that, then I would just say, how many times does 6 go into 72? I could literally, with my calculator, go 72 divided by 6, and that will give me 12, because this vinculus just means divide by. Top number, divide by bottom number. But let's look at it another way, shall we? I think I should. You can actually cancel diagonally when you have multiplication. What am I talking about, cancel? Let's see. So if I have 8 and 2, do these two have a common factor? And they do. If I divide 2 by 2, I get 1. Divide 8 by 2, I get 4. So these are equivalent. They work out because diagonally, we've canceled them. So what are the factors of 3 and 9? 3 goes into 9 3 times. So without having to do all that extra work, 4 times 3 gives me 12. 1 times 1 gives me 1. And any number over 1 is just that number 12. So don't forget that you can go diagonally, find common factors to cancel these things out, and make your life a whole lot easier.